Hello dear students, I welcome you all to the fifth video on relation and function class 11 mathematics. Okay, so the topic for the day is, as you can clearly see on the board, it is real valued function. Now, as you have already understood about functions, okay, so let me take two sets because we know that a function is a relation and a relation exists in between two sets, isn't it? So let me take any two sets. So this is my one set, let me call this as A and let me call this set as set B, okay, and there is a function f from A to B, okay. So we know that if f picks up x, okay, then it gives you fx, isn't it? And let me call this fx equals to y. All right. Now, real valued function is a function whose value, okay, whose value or ultimate value, that is y, because f is picking up x and giving me fx, that is y. That means y is the ultimate value, isn't it? So if my ultimate value is a real number, then such kind of function is known as real valued function. Okay, so in this particular exercise, what we are going to do is we are going to find what is the domain of the real valued function, all right, and domain is represented by df, all right. So whenever you see this means domain of function f, all right, and you will be asked to find what is the range of the function as well, and range is denoted by r of f, all right. So with this, let's begin our exercise 2.4. So the first question for the day, and taking question number 2, question says if fx is equals to x square, find this particular quantity. Now it's very simple, all right. So let's see how to evaluate. So what you can do here is, first you can evaluate how much is f of 1.1, all right. So let's see what is f of 1.1. Now instead of x I have 1.1, isn't it? So here I am going to write instead of x 1.1. So we have 1.1 squared, all right, fine. Now next is we have f of 1. So f of 1 can be written as how much? It can be written as, instead of x it is 1. So that's why instead of this x also I need to write 1 square, all right. Let's not evaluate this, okay. So let's directly put these two in this particular expression. So we have therefore f of 1.1 minus f of 1 by 1.1 minus 1. So how much is this? This is 1.1 square, isn't it? Minus, what is f of 1? f of 1 is 1 square. We have 1.1 minus 1. Now you can apply a square minus b square formula here, isn't it? So if you apply a square minus b square, then you will get a plus b into a minus b divided by, what do we have in the denominator? We have this one, isn't it? Now these two are same, so they'll get cancelled. Now you are left with 1.1 plus 1, and how much is this? This is equals to 2.1. So the value of this expression will be 2.1. So pause the video and note it down. Next we have question number 4. Now question says, is the relation f defined by this function? Justify your answer. Okay, so you know that any relation will be called a function if every element of the first set is mapped, yes, and on top of that every element of the first set is mapped only once, isn't it? So you should not have one element being mapped to many elements. That's what is the definition of function. So whenever you see this kind of function, what is happening here? There is a split, isn't it? See, in between 0 to 3, when x lies in between 0 to 3, then my functional value is, this is called functional value. So functional value is x square. Whereas if my value of x lies in between 3 and 5, then the value of function becomes 2x, isn't it? Yes? Okay, so such kind of function is known as split function. All right. Now we don't know whether this is a function or not, but if they say that this is a function, then this is called split function. There is a split here, okay. And if you want to check whether this relation is a function or not, how you need to check? You need to check at the point of split. For example, here the different values for x given to be are 0, okay, and 3 for the first one. Alright, and for the second one we have the value of x splitting between 3 and 5. Okay, so there are basically 4 points given to us. One is this 0, another is this 3, another is this 3, and the last one is 5. Alright, so there are 4 points given to you. So let's check what is the value of this function or this relation at these 4 points. Alright, okay, so we have when 0 is less than equals to x is less than equals to 3, yes, then fx is equals to how much? Fx is given to be x squared. Alright, now let's check at, okay, so at x equals to 0. Now you can clearly see that there is equal to sign also given to you, isn't it? So when x is equals to 0, then we have f of 0. Alright, so instead of x I am writing how much? 0. So we get this becomes 0 squared, which is equals to how much? 0. Alright, fine. Now at x equals to, what is the other point? Other point is given to be 3, because there is x equal to 3, so that's why I am taking x equals to 3. Now then we have f of x, how much is x? X is 3, so this is equals to, from this we have x is 3, isn't it? So this becomes 3 squared, which is 9. Alright, so this is my first case. Alright, now let's take the second case here. So we have when 3 is less than equals to x is less than equals to 5, then what is the value of function? Then fx is equals to, when this happens, then the value of function becomes 2x, isn't it? Now let's see what are the values when x is equals to 3 and when x equals to 5. Okay, so at x equals to 3, you can clearly see that there is equal to sign. So at x equals to 3, then my f of x, x is how much? 3. So this will be equals to 2 into x, and how much is x? X is taken to be 3, and how much is this? 2 into 3 is 6. Alright, fine. So we have at x equals to, the point is 5, then fx, that is f of 5, will be equals to 2x, isn't it? And what is x? X is equals to 5. So how much is this? 2 into 5 is 10. Now if you see here carefully, 0 is mapped to 0. This function is mapping 0 with 0. Alright, and this f is mapping 3 with 9. Alright, now here the same relation, I'm sorry I am referring function here, but it's a relation, given its relation. Now this relation f maps 3 to 6 here. Yes, and this maps 5 to 10. So basically here I am having problem with this. Here we have got 3, okay, and this 3 is mapped to 9, and here also we have got 3 which is mapped to 6. So one element, that is 3, is mapped to 2 different elements, isn't it? That is 9 and 6. But this should not happen in case of function, isn't it? So you will write, since 3 is mapped more than once, we say that, or you can write, hence f is not a function. Alright, so that's what you are going to write at the end. So pause the video and note it down. Alright, so next we have question number 6, which says if a real function f, so function is given to be real valued function, is defined by this, find x such that fx becomes 15. Alright, so it's a very simple problem. So given is given is fx equals to 15 here. Alright. And what is the value of fx? Fx is given to be 2x squared minus 3, isn't it? And this equals to 15. So from here you just need to find the value of x, which is very quite simple, right? So we have 2x squared equals to, this goes over there, becomes 18. So we have x squared equals to 9. So from here x will be equals to how much? Square root of 9. Therefore, what is the value of x? The value of x will be plus minus 3. So pause the video and note it down. Next we have question number 9. So let me read question for you. So a function f is defined by fx equals to 2x squared plus 3 for all x belonging to set of real numbers. Find the image of minus 1 under f. Okay, and next is element or elements of the domain which has image 35. Question is very simple. They are just trying to fool you by making the question a bit complicated. Okay, so again let me draw arrow diagram for you. This is my set A, this is my set B, this is my function from A to B. Alright, so this function picks up x and gives me fx, isn't it? And let me call this fx as y. So what do you say? So you say that y, okay, the elements from the second set, or you can say the elements of the range are the image, isn't it? So this y, which is fx, is the image of x under f. So that's how we read this. And this x is called the pre-image of y under f. Okay, so having understood this, let's see what is the meaning of this. So question says, find the image of minus 1. So instead of x, okay, so as I said earlier, fx is the image of x. So the image of minus 1 under f will be what? It will be f of minus 1, isn't it? So basically minus 1 is here and this f picks up minus 1 and gives me f of minus 1. And this f of minus 1 is called the image of minus 1 under f. So that's what we need to find. That is, we need to find f of minus 1. Okay, so given is this one. So number 1 is the image of minus 1 under f is how much? It is f of minus 1, isn't it? So what is x here? Fx here, fx is 2x squared plus 3, and instead of x I am writing minus 1. So that's why this becomes 2x squared plus 3, and how much is x? X is minus 1. So we have, this is minus 1 squared is 1. So 2 into 1 is 2 plus 3. So my first answer is 5. Alright. So next we have element or elements of the domain. Okay. So you need to find the value of x, because the question says element or element of the domain. So domain, elements of the domain are represented as x. Alright. So you need to find the value of x, and that x has the image 35. So basically what is given to us? Image is given, that is fx is given, isn't it? So fx is given to be 35. You need to calculate what is the value of x. Alright. So in the second case, given is fx. Okay, image is given to be how much? 35, isn't it? Now from here you need to calculate what is the value of x. Now what is fx? Fx is 2x squared plus 3, isn't it? So we have this equals to 35. So from here we need to calculate what is the value of x. Alright, so we have 2x squared equals to, so this 3 goes over there, becomes 32. So from here we have x squared equals to 16. So therefore from here x turns out to be square root of 16, which is plus minus 4. So your answer for the second part is how much? Plus minus 4. So pause the video and note it down. So next we have question number 11. So question says a function f defined by fx equals to x squared plus 3, x belongs to set of natural numbers and x is less than or equals to 5. Okay, so basically let's try to understand what is the meaning of this. This means x is a natural number and x has to be less than or equals to 5. So what are the numbers, natural numbers, which are less than or equals to 5? The numbers are 1, 2, 3, 4 and 5. There's equal to sign as well. So the numbers are 1, 2, 3, 4 and 5. So there are 5 values for x. Yes. and the values of x gives me what? Gives me domain, remember, alright. So the values of x gives me domain and the values of y, that is fx, gives me range, alright. So basically here given is, so this question is similar to question number 10, you will try 10 by yourself, okay. So given is domain, isn't it? So as I said, domain of f, that means the values of x are what? The values of x are 1, 2, 3, 4 and 5. Alright. So we can take the values of x only 1, 2, 3, 4 and 5, not the other ones. Alright. Fine. So you need to find what is the range. So range gives me the values of y, isn't it? Values of y or fx. So let's see what are the different values of fx for different values of x. Alright. So therefore f of x, now first value for x is 1. Alright. So f of 1 from here turns out to be x is square, that is 1 is square plus 3, and how much is this? This is 4. Alright. Similarly we have f2. So f2 will be 2 square, that is x square is 2 square plus 3. So 2 square plus 3 is 7. Okay. So we have f3. So this is x square, that is 3 square plus 3. So 3 square is 9, 9 plus 3 is 12. Similarly we have f4 equals to 4 square plus 3. So 16 plus 3 is 19, and we have at last f of 5. So f of 5 means 5 square plus 3. So 25 plus 3 is 28. So these are the only values, possible values of fx, isn't it? Because we cannot take f6, because in domain we have got the numbers till 5 only. The value of x will be till 5 only. So that's why we cannot take f of 6. Alright. So therefore your range of f, or you can write rf, will be equals to these numbers, the possible values of fx. So we will get 4, 7, 12, 19 and 28. So this will be the range of your function. Okay, so this is my first one. So this is my first answer. Second says find f2 into f5. So second part is also easy. So this is my second part. So second part says f2 into f5. So instead of, see here carefully, okay, so we have f2. How much is f2? f2 is 7, isn't it? So we have 7 into f5. f5 is how much? f5 is 28. So you just need to multiply this, isn't it? So 7 into 8 is 56. Carried over 5. 7 into 2 is 14 plus 5 is this much, isn't it? So your answer for the second part is 196. Third one says, does f of minus 3 exist? That means, what is the value of x here? The value of x is minus 3. That means, this minus 3, is this included in the domain? No, right? So since minus 3 is not included in the domain, so that's why f of minus 3 do not exist. Alright. So number 3, as minus 3 do not belong to what? Domain. Okay, so you can write this as df, do not belong to df, hence f of minus 3 do not exist. Alright. Last part is very simple, isn't it? So you will try number 4 by yourself. Alright. So you will do this by yourself. So pause the video and note it down. Now we are going to start the very important problems, as you are going to face these kind of problems in your competitive exams as well. So in this particular question, question number 12, there are exactly 4 questions given to you. I am taking question number 1 and 3. Okay, so the function here are given to be real functions, as you can clearly see, right? So you need to find what is the domain. Now function being real means the overall value or the ultimate value, that is this, isn't it? So fx is the ultimate value. So this is my ultimate value here. So this has to be a real number, and This is what kind of function? This is a rational function or fractional function. Yes, because you can see that there is a fraction given to you. So a fraction will be a real number if we don't have the denominator to be 0. So what should happen here? Here this denominator should not be equals to 0. Okay, now when will this be equals to 0? Let's check. Okay, so we have denominator will be 0, that is x plus 2 will be 0 if x becomes minus 2. Are you understanding? That means if x is minus 2, then this full thing is how much? This is 0, and we should not have x equals to minus 2. That means x can be anything, and we know that domain is what? Domain is the all possible values of x, isn't it? So the value of x can be anything other than minus 2 in order to have this to be a real number. Alright, x cannot be minus 2, isn't it? Because if x is minus 2, then this denominator becomes 0. So we want to get rid of this condition, that is the denominator being 0. So my domain will be, therefore domain will be any real value. Alright, so you can have any real value other than minus 2. That means I need to remove minus 2. So let us remove minus 2. Okay. So you have to always put this bracket. Remember, you're from a real line, you're eliminating a set containing minus 2. Alright. So that's why this will be the domain for this particular function. Okay, so let's check with the second one. So again here also we should not have the denominator to be 0. So let's check when does this denominator will be 0. So we have denominator, that is x square plus 3x plus 2 equals to 0. Now this is what kind of equation? This is quadratic equation. So you can make use of either quadratic equation formula, or you can make use of middle term break. So let's quickly find what is the value of x here. So we have okay, so after factorization you will get this. So what is the meaning of this? So either this must be equals to 0 or this must be equals to 0. So if this is 0, that's x plus 2 is 0, then what is the value of x? X becomes minus 2. Yes, so therefore x is equals to minus 2 from this, and if this becomes 0, x plus 1 equals to 0, then from here the value of x turns out to be minus 1. So basically from here we see that if x is minus 2, then this becomes 0, denominator becomes 0, and if x is minus 1, then also this denominator becomes 0. So I don't want minus 2 and minus 1 in my domain. Alright, so in my domain we can have any real number other than minus 2 and minus 1. Alright, so therefore my domain for this particular function will be any real number except minus 2 and minus 1. Alright, so this will be the domain for this particular function. So pause the video and note it down. So next we have question number 13. Again the question is same, find the domain of the following real valued function. So in this case also fx is given to be a real number, but here we see that there is square root sign, isn't it? So whenever you have square root sign, now within this square root sign whatever quantity is there, for example here we have got this and here we have got this. Now this quantity should not be negative, alright, because we cannot have square root of negative number, isn't it? So that's why here this quantity must be, can it be 0? It cannot be negative, we understood that. Can it be 0? Yes, it can be 0. So that means we have, for the function to be real valued, okay, so for the function for the function to be real valued, we said that 2 minus 3x can be equals to 0. Yes, Cannot be negative, we understood that. Can be equals to 0 because square root of 0 is a 0, right? And 0 is also a real number. Okay, now can it be positive? Yes, because we know that square root of positive number is always a real number. So that's why 2 minus 3x will be greater than or equal to 0. So from here let's calculate what is the value of x. So from here we have minus 3x will be greater than equals to minus 2. Now in order to get rid of minus sign, we need to multiply both sides by minus, and whenever we do that, what do we get? We get that this sign will reverse, isn't it? So we have this much, and here we get x is less than or equal to 2 by 3. Alright, so let me draw a real line for you. I hope you remember intervals as a subset of R. Yes, so there is a real line here. So let me plot 2 by 3. So it might be somewhere over here. Alright, so if this is my 2 by 3, x is equal to 2 by 3, isn't it? So equal to means 2 by 3 is also included. So if I include, then I have to draw, or I have to put a circle, bold circle, isn't it? Now x is less than 2 by 3. So less than means we have to come this way. And do we have the lower bound? We don't have lower bound. That means this keep on continuing, right? So that means this continues here. It keep on continuing this way, right? So that means it start with minus infinity and end up till 2 by 3. That means we have x belonging to, x must come from minus infinity and must end in 2 by 3. So starts with minus infinity. So minus infinity is always included in open, and 2 by 3. So 2 by 3 is included. So that's why 2 by 3 will be closed here. Alright. So x belongs to this particular interval. Now this interval is also a set, isn't it? We know that intervals are subset of real line. So that's why this is also a set. So x belongs to this means this becomes my domain. Alright, so therefore domain for this function will be how much? It is minus infinity comma 2 by 3 closed. Alright, so this will be the domain for this particular function. Now let's have a look at this question. Again we have got square root sign. Okay, so we are going to write the same. So for the function to be real valued, what do we need to do here? We need to see that whether this x minus 1 can be equals to 0 or not. Now since this is in the denominator, we cannot have this equals to 0, because if I keep 0 in the denominator, then the function or this fraction becomes undefined, isn't it? So I cannot have this x minus 1 to be equals to 0, remember. So that's why this always need to be positive, that is greater than 0. So from here what do we get? We get that x is greater than 1. Alright, so x is greater than 1 means if I draw a real line, alright, and this is my 1, can I include 1 here? No, because x is strictly greater than 1, isn't it? So there is no equal to sign given, so that's why I need to exclude this one. Alright, so I have excluded 1, and x can be any other number greater than 1. So any other number greater than 1 means this way, and if we go this way we are going towards infinity, isn't it? So that's why my x belongs to this set, that is this interval. Now it starts with 1, so since 1 is not included, so that's why this has to be open, and it ends or it goes till infinity. So it goes till infinity and it's going to be always open. Alright, so it's going to be 1 comma infinity. So if x belongs to this set, then domain, therefore domain of f for this function will be how much? 1 comma infinity. This is my open interval. So pause the video and note it down. Next we have question number 14. So again we have find the domain of the following real valued function. So here we see that all are given in modulus. Okay, so wherever you see modulus, there you can apply a special formula. So this formula is given out here. So any modulus function fx equals to mod x can be splitted. Okay, so it can be written in split function. So it will be equals to mod x will be x if x is a positive number or equal to 0. Okay, and it can be written as minus x if x is less than 0. You need to remember this, because this very same thing is going to be repeated again and again in your class 12 first chapter in calculus. Okay, so you need to remember this. So here all these are given in modulus format. Okay, so you need to find the domain of the functions such that fx becomes your real number, because function is given to be real function. Now, are we having any problem if I choose any value for x? No, because there is a modulus sign, and here this is not given in fraction, isn't it? So you can choose any value for x and you will always get a real number out here. In fact, you will get always a positive number, isn't it? So my domain here will be equals to any value from your real number, because I am not having any problem here with the function. Similarly, here my domain will be, again, if I choose any value, since I don't have here a fraction, so if I choose any value for x, I will always get the value of function to be a negative number, because there is a negative sign outside modulus. This is always going to be positive, so we have outside negative. So that's why this is also always going to be negative. So I can choose any value for x. So that's why my domain will be R here again. All right. Next is, again same, we don't have any fraction here. Put any value for x, you will get a real number here. So that's why your domain in this case will be R. Now here we see that there is a fraction, and in a fraction we should not have denominator to be 0, and this denominator will be 0 if x is equals to 0, isn't it? So that's why my domain here will be any real number other than 0. So that's why I am removing said containing 0. So these are the domain, and as I said, you need to memorize this formula, because these will be useful in the upcoming few session, and the very same thing is going to be useful in class 12 as well. So pause the video and note it down. Now, as we are aware of finding our domain, yes, now we will move to the problems where we are going to find the range as well. Okay, so we are quite confident now for finding domain. So that's why let's make use of one new formula for finding range. See, it's not necessary that you are going to use the very same formula for finding range. You can use the other techniques as well, but I find this to be pretty simple. So that's why I'm going to make use of this particular formula. So before I derive the formula, let's have a look at, or let's see what we have already done, and I'm going to talk about inverse relation. Now, if the relation R is from A to B, or if R is a subset of A cross B, then the relation is defined in this way, isn't it? Where this A, this first element comes from the first set and B comes from the second set. Now, if this is your R, then the inverse of this R is defined as R inverse, where this second element becomes your first element and this first element becomes your second element. But still, this second element comes from the first set and this comes from the set B. Alright, so this was your definition for R inverse. And one more thing that we knew was domain of R will be equals to range of R inverse, and range of R will be equals to domain of R inverse. Now we know that function is also a relation, isn't it? So that's why the same formula can be applied. Okay, so that means domain of F. Alright, so domain of F will be equals to range of F inverse. Okay, and similarly range of F becomes domain of F inverse. So these are the two formula that we are going to make use out here. Alright, so as you know, in function we have x and y, isn't it? Yes, that means function maps x to y, or in other words, In other words, let me write this way. If x comma y belongs to f, then this can be written as fx equals to y, isn't it? Yes. So if x comma y belongs to f, then in f inverse or within f inverse, we are going to have y comma x, isn't it? Are you understanding? See, a comma b belongs to R, that means b comma a. If I reverse the order, then that becomes, or that belongs to its inverse. So if I reverse the order, this becomes y comma x, and this must belong to f inverse. Now if I use this notation, this f is mapping x to y, isn't it? So this f inverse maps y to x. Are you understanding? So f inverse maps y and gives me what? Gives me x. Alright, so that's what you need to understand. So that means if we have fx equals to y, okay, so from here if you want to find its inverse, then we get what? This f goes over there, becomes f inverse y equals to x. Alright, so this also needs to be memorized. Alright, so you may pause the video and note down the important points. So the question 15 says find the range of the following functions. So fx is given to with this, and there are two questions given here, so let me do one question at a time. So we are going to make use of the formula which we have just noted down, that is domain of f inverse will be equals to range of f. Alright, and we need to find what? We need to find range of f. So let's first find f inverse. Alright, now we know that if fx is equals to y, then f inverse x, this goes over there, becomes f inverse y will be equals to x, isn't it? So you will first find, in order to find f inverse, you need to find what is your x. Alright, that x gives you your f inverse, remember that. Okay, so we have from here, so let me write this as y. Okay, so fx is written as y because we have fx equals to y, isn't it? So fx equals to y is equals to x squared plus 2. Okay, so as I said, we need to find what is the value of x. So we have x squared equals to y minus 2, and from here we have x equals to square root of y minus 2. Alright, now this x gives you f inverse, isn't it? Alright, so we have x can be written as f inverse y. X can be written as f inverse y, and this f inverse y is equals to how much? It will be equals to y minus square root of y minus 2. Now, since this is a real valued function, alright, again within square root sign whatever comes, that has to be always, see, there is no fraction, so that's why this has to be always greater than or equal to 0. Alright, so for the function to be real valued, we must have y minus 2 must be greater than equals to 0, that is y must be greater than equals to 2. Yes, so if I draw again the numbered line, this is my 2, so 2 is included, so we have 2 included and it continues. So that's why this particular interval is what? It starts with 2 and end with infinity, isn't it? So that's why for this f inverse, what is my domain? Our domain is this. Alright, so therefore domain of f inverse. Alright, remember domain of f inverse is what? It turned out to be 2 comma infinity. Alright, so therefore range of f, which is domain of f inverse, can be written as close interval 2 comma infinity. Alright, so this is my answer for this particular question. Now let's see that problem. So here again I am going to do the same. So fx is written as y, so y is 3 minus 2x. So from here let's find x. So this comes over here, becomes 2x, so 3 minus y. So from here we get that x is equals to 3 minus y by 2, isn't it? So from here this x can be written as f inverse y equals to 3 minus y by 2. Okay, so if you see here carefully, this y is in the denominator, right? So we don't have any problem with the, this y is in the numerator, so we don't have any problem with the denominator, isn't it? So you can choose any value for y in order to make this to be a real value, isn't it? So that's why there is no square root sign as well, so that's why we don't have any problem here. Y do not belong to the denominator and it do not belong to the square root sign, so that's why we don't have any problem if I choose any value for y. Alright, so therefore domain of f inverse, alright, so this is f inverse, remember. So domain of f inverse turned out to be r here, real number, you can choose any value. So therefore range of f, we need to find range, so range of f, and using the formula we have domain of f inverse which is equals to r. So this will be my answer for this particular question. So pause the video and note it down. So next we have question number 17. I am taking question number 3 only. So here fx is given to with this and you need to find what is the domain and range of this function. Alright, so let's begin. So we have, let's find first domain. So finding domain is easy, isn't it? Because for finding domain we must have this, since this is in the denominator, this has to be always positive, that is greater than 0. Alright, so we must have x minus 5 greater than 0, that is x must be greater than 5. So if x is greater than 5, if you draw a real line, mark 5 is not included, as you can see there is no equal to sign, so you can go this way. And what is this interval? This is open 5 comma infinity, isn't it? So therefore domain, or you can directly write df will be equals to 5 comma infinity, open interval. Alright, now you need to find what is the range. Now for finding range, whenever there is square root sign, it's very easy. Now what is the meaning of range? Range means all possible values of y, isn't it? Yes? Okay, so that's why we have range of f. Okay, so all possible values of y or all possible values of fx, and we know that this is always positive, isn't it? Because whenever x is greater than 5, this is going to be a real number, in fact not positive, it's going to be a real number, because square root of any positive number is a real number. Yes, so that's why it's going to be always real number. Alright, so the set of reals gives me the possible values of fx, and that's why my range will be r in this case. Alright, so pause the video and note it down. Alright, so we have question number 17. So question says find the domain and range of the following functions. So this is the first question. So question says you need to find what is the domain, right? So finding domain is easy. So whatever is there within this square root sign, we must have that to be equals to or greater than 0, isn't it? So therefore we must have, alright, so let me directly write, we must have 16 minus x squared must be greater than equals to 0. Alright, now whenever you have quadratic expression, see whenever it is linear, that time it's easy, we have already seen, but whenever you have a quadratic here or more than, or can I say cubic equation or to the power equations, then what you can do or what you have to do here is you have to go for factorization. For example, if you factorize this, this becomes your 4 minus x into 4 plus x using a plus b into a minus b formula, isn't it? So this is equals to 0. Now see here carefully, make this equals to 0. Alright, so make this equals to 0. I am telling you the rule, make this equals to 0 and find the value of x. So if you make this equals to 0, then you will find that x will be plus minus 4, isn't it? Are you getting it? Okay, so after finding the value, you will draw a real line and there you will plot minus 4 and 4. Alright, the values of x. Okay, now let us take the value of x to be minus 4. Right? So if this is minus 4, then what happens? This whole quantity becomes 0. And can I have this equals to 0? Yes, there is equal to sign, isn't it? So that's why if I make x equals to minus 4, this quantity becomes 0. So 0 into this becomes your 0. So I can have the value of x to be minus 4. Alright. Why am I finding value of x? Because I am finding domain, and domain contains the value of x, isn't it? Alright. Now can I have x equals to 4? Definitely, because if x is equals to 4, then this becomes 0, and 0 into this is also 0, and the value of this full thing, that is this, can be equals to 0. So I can have plus 4 as well in my domain. Alright, fine. Now let us choose. See, there are 3 regions out here if you see carefully. One is this region, right? One is this region, another is this region, and the last one is this region. Alright, fine. So let's go to region 1 and choose any number. For example, minus 5 lies over here, isn't it? So if x is minus 5, let's see what happens here. So if x is minus 5, then this becomes 4 minus of minus 5. Alright, this becomes 4 minus 5. Are you understanding? I have chosen one number from here, that is minus 5. So this is equal to, let's see how much is this equals to. This is 4, this minus into minus plus. So 4 plus 5 is 9 into this is minus 5, isn't it? So I'm sorry, this is minus 1. So this is minus 9. This is negative, isn't it? But I cannot have this to be negative. Are you understanding my point? This has to be greater than or equal to 0. So this is negative, which is less than 0. So this is not possible. That means here in this region 1, if I choose any number, I see that this is going to be always negative. Alright. So we have 4 minus x into 4 plus x will be negative here. Alright. So I cannot choose this. My value of x cannot lie in this region 1, because if I choose any value of x in this region 1, this quantity is going to be negative, but I don't want that. Alright, fine. Now let me choose any other value. Okay, so let me go to region 3. So choose any number, for example 5. Can we choose 5 in region 3? Because 4 is here, means 5 will be here, isn't it? So if my number is 5, then this becomes, let's see how much is this going to be. This is minus 1 and this is going to be 9. So minus 1 into 9 will be again minus 9. So this region is also not possible. Alright, so here also I see that 4 minus x into 4 plus x will be negative. Now we are left with only region 2, isn't it? So in region 2, see here carefully, in region 2, choose any number. For example, you can choose 0, because minus 4, in between minus 4 and 4 we have 0 as well. So if I put the value of x to be 0, then this becomes 4 minus 0 into 4 plus 0, which is going to be equals to 16, isn't it? And 16 is greater than 0, isn't it? So choose any number here, you will find that 4 minus x into 4 plus x is always going to be greater than 0. Alright, so that's why you can choose your values in between minus 4 to 4 only. If you go beyond them, then you will find that your product, that is this, is going to be less than 0. Alright, so therefore x belongs to what? X belongs to always this interval from here to here, isn't it? And what is this interval? This is starting with minus 4 and ending up with 4, and both are included, isn't it? So that's why we have x belonging to closed interval minus 4 comma 4. Alright, so if x belongs to this set, then domain of f, domain of this function will be equals to how much? Closed interval minus 4 comma 4. Alright, so this is my domain. Now let's find what is the range. Now here, in such cases, you need not find f inverse. Alright, now what is the meaning of range? Range means all possible values of fx, isn't it? So for example, if this is my set A, this is my set B, this function f, and this is my x, and gives me fx, or I can call this as y as well. So set of all those y gives me the range, isn't it? That is, set of all fx gives me the range, isn't it? So that's why Here, what are the possible values of fx? Here you will see that, what is this? This is my fx, isn't it? And fx is always positive, greater than or equal to 0, isn't it? So greater than or equal to 0 means 0 is included. So if this is my 0, 0 is included and it continues, isn't it? So end up with infinity. So you can have any value, fx takes any value in between 0 to infinity, isn't it? So that's why my range will be equals to closed interval, start with 0 and end up with infinity. Alright, is the question clear to you? So pause the video and note it down. Okay, so let's take question number 3. Actually, this is question number 18. Alright, so I have forgotten to mention this is question number 18, I guess. No, sorry, this is question number 19, not question number 18, question number 19. So I have already done the first question. Let me take the third question for you. So again, you need to find domain and range. So domain. Okay, so for domain, this must be always positive, isn't it? So we must have 4 minus x square always greater than or equals to 0. So again, the rule says 4 minus x into 2 minus x into 2 plus x will be greater than 0. So the rule is same. Again, you will draw a real line. Now if this is equals to 0, then the values of x will be minus 2 and plus 2, isn't it? So minus 2 and plus 2 has to be plotted. Alright. Now, can I take x equals to 2? Let's check. If x is 2, then 2 minus 2 is 0. So 0 into anything is 0. But this cannot be, this full thing cannot be equal to 0, isn't it? So that's why x equals to 2 has to be excluded. So that's why I am excluding this. So 2 is excluded. Alright. Similarly, x equals to minus 2. If you put x equals to minus 2, this becomes 0. So altogether this also becomes 0. So minus 2 also needs to be excluded. Alright. Fine. Now this has to be positive. Now again we have got 3 regions out here. This is my region 1, this is my region 2 and region 3. Alright. Now let's check or let's choose any number from region 1. For example, minus 3. Yes. So if I choose minus 3, then this becomes, see here carefully. So this becomes 2 minus of minus 3. This becomes 2 minus 3 and this is how much? This is 2 minus into minus is plus, so this becomes 5 and this becomes minus 1, so this is minus 5. So this region, that is region 1, cannot be chosen because this is negative, isn't it? This product is becoming negative, but this has to be positive. So similarly, you'll find that if you choose any number from region 3, that is, if you choose 3, then also this is going to be negative. Again, you will get minus 5 if you choose 3. That means the only possible is going to be this, but still we need to check. Alright, so let's check, or let's take any value in between this, and that is 0 you can take. So if you take 0, then this becomes, so 2 minus 0 is 2, 2 plus 0 is also 2, so 2 into 2 is 4. So this becomes positive, isn't it? So only in this we are going to have this product to be greater than 0, isn't it? So that's why from here we can conclude that x belongs to what? X belongs to this interval. And what is this interval? Minus 2 and 2. They are not included. So that's why this is open interval minus 2 comma 2. So if x belongs to this, then the domain for this will be, therefore domain will be open interval minus 2 comma 2. Alright. Now what about the range? Now range will be, if you see here carefully, this is always positive quantity. Square root of positive gives me a real number. So 1 divided by any real number will be always a real number. So that's why your range will be real number here. Okay, the possible values of fx will always be a real number. So pause the video and note it down. So next we have question number 18. So let me read the question for you. Question says find the domain and range of the following functions. So I'm taking 1 and 2 for now. So let me take question number 1. So you need to find domain. So for finding domain, whenever you see a fraction, you always need to remember that denominator should not be equals to 0, right? So we have x minus 4 equals to 0. That is, denominator will be 0. So from here, what is the value of x? X turns out to be 4. That means if x is 4, then my denominator is going to be 0, isn't it? So that's why I need to make sure that I don't have x equals to 4. So therefore, domain will be any real number other than 4. Alright, so this will be my domain. Okay, now for finding range, here we have got some pattern if you see. That is, if you take minus common from wherever, right? So for example, if I take minus common, then this becomes minus x minus 4 divided by x minus 4. So these two gets cancelled and I get minus 1. So basically fx is taking the value minus 1 for whatever value of x. So if you choose any value of x other than 4, then the value of x will be only minus 1. Alright. So the possible values of fx, if I put them in a set, then that gives me the range, isn't it? So that's why my range will contain only one element, that is minus 1. Alright, so this will be my domain and range for this particular function. Alright, fine. Now here also we have got the same. We have got fraction, so that's why we have denominator is 0 if x becomes 3. So that means my value for x should not be 3. So therefore, my domain will be any real number other than 3. Alright, now what will be my range? Now range, if you see here, so if I apply factorization formula, we have x minus 3 and x minus 3 gets cancelled, so it will be x plus 3, isn't it? Now that means if you choose any value for x other than 3, right? If you choose 3, first see here carefully, if you choose 3, then this becomes how much? 0, yes? But the value of x cannot be 3, isn't it? If you choose 3, if you choose 3, then this becomes 3 plus 3, which is 6. But the value of x cannot be 3. Because you have excluded 3, isn't it? So that's why the value of fx cannot be 6. But you can have any other value other than 6, isn't it? So that's why my range will be any real number. The functional value will be any real number other than 6. Alright. So I am removing 6 from here. So my domain will be this much and range will be this much here. So pause the video and note it down. So next we have fx is given to this one. So let's find what is the domain and range. So for finding domain, again this is a fraction, so this should not be equals to 0. So we have denominator, that is 2x plus 1 will be 0 when x is equals to minus half, isn't it? So from here you will find that x will be minus half. So that's why your domain will be any real number except minus half. So remove minus half. So this gives you the domain. Now in order to find range, okay, so in order to find range, what you can do here is you can again go for your inverse. So let's find what is the inverse from here. Alright, so since fx is y, yes, so instead of y, fx I am writing y. So y is equals to x plus 1 by 2x plus 1. So let's find what is the value of x from here. So let's do the cross multiplication. So we have x plus 1 will be equals to 2xy plus y. So from here this comes over here. Let me take this 1 over there. So we have x common, so 1 is left, and from here minus 2y is left. So this becomes y minus 1, and from here we have x equals to y minus 1 divided by 1 minus 2y. So, and what is x? X is f inverse, isn't it? So this is f inverse y equals to y minus 1 divided by 1 minus 2y. Now to find range of f, we will find domain of f inverse. Now to find domain of this should not be equals to 0, isn't it? So we have 1 minus 2y equals to 0. That is, denominator will be 0 if y is equals to half, isn't it? Yes. So therefore domain of f inverse from here turns out to be any real number other than half. The value of y should not be equals to half. If this is half, then this denominator becomes 0. So any real number other than half. So that's why I am excluding half. So if this is my domain of f inverse, then you will write that range of f. Alright, so range of f will be domain of f inverse, which is how much? R minus half. Alright, so pause the video and note it down. Okay, so next we have question number 21. Now this is the given function and you need to find domain and range, and we have already found the domain of this in the one of the question that we have done earlier. So domain will be any real number other than 0, isn't it? So we need to exclude 0 here. So let me directly write domain here. So domain will be R minus 0. We have already seen this. Now let's find what is the range. Range means all possible values of fx should be put in a set. Alright, and we know one more thing, that is the definition of modulus function, which says x if x is greater than or equals to 0 and minus x if x is less than 0. Let's make use of this formula here. Okay, so we have fx equals to, okay, so we have mod x minus x by 2x. Now let's make use of this definition here. So we need to split here, and we have got two options, that is if x is greater than or equals to 0, and another one is if x is less than 0. Alright, so here we will change only this one because only this contains the modulus. So others will remain as it is, that is minus x 2x. So minus x by 2x, they will remain the same. Now if x is greater than or equals to 0, if x is greater than or equals to 0, then this modulus x becomes how much? It becomes x, isn't it? If x is greater than or equals to 0, then modulus x becomes x. So that's why instead of modulus x, I am writing x here. Alright. Now if x is less than 0, then modulus x can be written as minus x, isn't it? So instead of modulus x, I am writing minus x here. Okay, fine. Now x minus x is how much? It is 0, isn't it? So we have 0 by 2x will be 0. That means fx will be 0 if x is positive. Yes, so if x is greater than or equals to 0. Alright, now how much is this? This is minus x is minus 2x. So minus 2x divided by 2x is minus 1. So it will be minus 1 if x is less than 0. That means the function takes only two values, that is 0 and minus 1, isn't it? So that's why range of the function will be the possible values of the function. So the possible values of function are minus 1 and 0. So this will be the range for this particular function. So pause the video and note it down. So next, that is question number 22, is also similar question. Again we have got modulus function here. So domain is easy. So denominator should not be equals to 0. So denominator will be 0 if x is equals to 4. So that's why domain will be any real number other than 4. Alright, so this is my domain. Now let's find range. So again let me make use of modulus formula. So mod this is equals to mod of x minus 4 by x minus 4. Alright, okay. So let's observe here. So we have, let me define this function x minus a. Alright, so if I call this as capital X, then this becomes modulus of capital X, isn't it? And we know that modulus of capital X can be written as capital X if capital X is greater than or equals to 0. Alright, and minus of capital X if capital X is less than 0. Okay, now what is capital X? In fact, capital X is x minus a, isn't it? So that's why this becomes x minus a if x minus a, instead of capital X I am writing x minus a greater than or equals to 0. Now what is the meaning of this? This means that if it goes over there, this becomes x is greater than or equals to a. Alright, and this becomes minus of x minus a is how much? It is a minus x, isn't it? So when you multiply this by minus, then you will get a minus x. So if capital X, that is x minus a is less than 0, and x minus a is less than 0 means x is less than a. So that means this is one more formula. You may memorize this as well, or you may note down this as well. So instead of this I am going to make use of this here. All right, so we have two things, that is if x is greater than a, and what is a here? A is 4. All right, and other one is if x is less than a, that is if x is less than 4. Okay, so as this do not contain x modulus sign, so I can keep it as it is. So x minus 4 will remain as it is. The only change that occurs will be with this. Okay, now if x is greater than equals to 4, then this modulus will be equals to this number itself, x minus a. So that's why if x is greater than equals to 4, then this remain x minus 4. All right. Now similarly, if x is less than 4, then x minus modulus of x minus 4 becomes 4 minus x, isn't it? So this becomes 4 minus x. All right. Now these two gets cancelled. So how much is left? It is 1. All right. So the function will be equals to 1 if x is greater than equals to 4. And how much is this? If you take out minus common, again you will have x minus 4 getting cancelled, so only minus 1 will be left. So if x is less than 4. So basically we saw that the value of f will be 1 and minus 1, isn't it? That is the range. The function values take only two values, so that's why my therefore range for this will be equals to how much? It will be two values, minus 1 and 1. So pause the video and note it down. So let's take the last question for the day. So question says f and g are two real functions defined by fx equals to 2x plus 1 and gx is 4x minus 7. For what value or for what real numbers x, then these two happens. So there are two cases out here. So let's see this. We need to find the value of x here. So fx is given to be how much? Fx is given to be 2x plus 1 and gx is given to be 4x minus 7, isn't it? So this can be written as, so take this 2x over there, so you will have 4x, this goes over there, becomes minus 2x, isn't it? And this will come here, so we have 1 plus 7. All right, so from here you will get that 2x will be 8, and from here you will get that x will be equals to 4, isn't it? So this is the required value of x. Isn't it very simple? Very good. So let's go to this. Now this is also going to be same here. So we have fx is 2x plus 1 less than 4x minus 7. We can do the same. Get this thing out here, take this over there. So you have 2x minus 4x is less than minus 7 minus 1. Alright. So we have this minus 2x is less than minus 8. So if you want to get rid of minus 2, then you have to divide, or you want to get rid of minus, then multiply both sides by minus, then the sign will change, isn't it? This less than becomes greater than, so from here x will be greater than equals to, greater than 4. So therefore any number, any real number greater than 4 will give you fx will be less than gx. Alright, so pause the video and note it down. With this we close for the day. Thank you very much.